NASA is going to the bottom of the ocean to look for alien life. But what they found has nothing to do with biology. 13,000 feet below the Pacific Ocean, something impossible showed up in the data. Rocks are making breathable oxygen in total darkness. You've been taught your entire life that only plants and sunlight can create oxygen. Science just proved that wrong. This is the story of how NASA discovered dark oxygen, a finding that could change the rules of the universe. Because if you don't need a star to have air, you don't need a star to have life. In 2014, the deep ocean reminded us how dangerous it really is. A robot named Nereus was exploring the Kermadec Trench near New Zealand. It was one of the most advanced machines ever built, a $14 million deep-sea explorer that had already transformed our understanding of the ocean. Then, in an instant, it disappeared. At those depths, the pressure is extreme, like having an elephant standing on your thumb. Just one tiny crack is enough, and everything collapses. That's exactly what happened. Nereus was gone. For years after that, the deep ocean was effectively off-limits. No one wanted to risk losing another multi-million-dollar machine, so NASA changed its approach. Instead of building one massive, expensive robot, they applied a strategy from the space industry, the CubeSat philosophy. Build smaller, cheaper machines, and send many of them. That's how Orpheus was created. It's about the size of a motorcycle, costs less than $200,000, and runs on the same navigation software used by the Perseverance rover on Mars. NASA is testing this technology in the ocean because of where they plan to go next. On Jupiter's moon, Europa, there is no GPS. A robot won't be able to rely on signals it has to navigate on its own. Orpheus does exactly that. It sees rocks, coral, and terrain, builds a map, and remembers where it is. It thinks for itself. In 2021, deep-sea scientist Andrew Sweetman conducted an experiment in the Clarion-Clipperton Zone of the Pacific Ocean. He deployed landers, sealed instruments that sit on the seafloor and measure how much oxygen is being consumed by microorganisms. Normally, oxygen levels decrease over time, but this time, something was off. Inside his chambers, oxygen levels didn't drop, they increased. At first, he assumed it was a mistake. He thought the sensors were faulty, so he discarded them and repeated the experiment with new equipment. The result was the same. Oxygen levels kept rising, sometimes reaching 3 times higher than the surrounding water. To rule out biology completely, he took an extreme step. He poisoned the water with mercury to kill all life inside the chamber. And still, oxygen levels continued to rise. At that point, there was only one conclusion left. This wasn't a biological process. The oxygen was coming from the rocks themselves. These rocks are known as polymetallic nodules, small potato-sized lumps rich in manganese, cobalt, and nickel. They grow incredibly slowly, just about 1 millimeter every million years, by accumulating metals from seawater. But what makes them extraordinary is their electrical behavior. These nodules act like natural geologic batteries. When scientists measured their surface, they detected electrical potentials of up to 0.95 volts. Individually, that's small, but when multiple nodules cluster together, the combined voltage becomes significant. Enough to trigger electrolysis. That means they can split water molecules into hydrogen and oxygen. In other words, they are literally generating oxygen in complete darkness. No sunlight, no photosynthesis, no living organisms, just geology, creating breathable air. This discovery challenges one of the most fundamental assumptions in science. Before 1977, scientists believed all life on Earth depended on sunlight. Then hydrothermal vents were discovered deep in the ocean. These are massive fissures in the seafloor that release superheated water up to 750 degrees Fahrenheit filled with toxic minerals. And yet, despite these extreme conditions, these vents are surrounded by thriving ecosystems. Species like the blind shrimp Rimicaris hybaceae have no eyes. Instead, they use specialized sensors to detect heat, essentially allowing them to see in complete darkness. The foundation of this ecosystem is a process called chemosynthesis. Instead of using sunlight, bacteria convert chemicals like hydrogen sulfide into energy. These bacteria form the base of the food chain, and organisms like shrimp actually farm and consume them to survive. NASA has a deep interest in these environments, because similar conditions may exist beyond Earth. Moons like Europa and Enceladus are constantly stretched by the gravity of Jupiter and Saturn. This creates internal friction, generating heat within their cores. That heat can drive hydrothermal activity beneath their icy surfaces. If Earth has hydrothermal vents, then these moons likely do too. And if that's true, then you don't need sunlight to sustain a food chain. You just need water, heat, and chemistry. But the most extreme form of life might not be in the ocean at all. It might be inside the planet itself. NASA scientists studied a gold mine in South Africa, nearly 3 kilometers below the surface. There, they discovered microbial communities that have been completely isolated for tens of millions of years. These organisms have never been exposed to sunlight. They have never interacted with plants. They have never even encountered surface water. Instead, they survive using energy from the radioactive decay of uranium in the surrounding rock. This is considered one of the closest analogues to potential extraterrestrial life, because Mars once had liquid water and sunlight. Today, it's a frozen desert. But deep underground, in cracks within Martian rock, similar microbial life could still exist, sustained entirely by chemical and radioactive processes. These organisms are essentially the blueprint for alien life on Mars. NASA isn't just studying these environments remotely, they're training humans for them. In the Florida Keys, 62 feet underwater, lies Aquarius, the world's only permanent undersea research station. NASA uses this facility for a program called NEMO. Astronauts live underwater for weeks at a time. They're called aquanauts. By adjusting their weight, they simulate the gravity of the Moon or Mars. They perform underwater spacewalks, where the resistance and risk closely resemble working in space. Because in many ways, the deep ocean is the closest environment we have to outer space. The conditions beneath Europa's ocean under miles of ice are expected to be remarkably similar to the deepest parts of Earth's oceans. Every mission in Aquarius is preparation for exploring alien worlds. So what did NASA actually discover? They didn't just find oxygen in the dark. They found that life and the conditions that support it are far more flexible than we ever imagined. The discovery of dark oxygen suggests that Earth has alternative ways of producing oxygen that don't depend on sunlight. It forces us to rethink long-standing assumptions about how life begins and survives. If oxygen can be generated by rocks, and life can be powered by chemistry or radiation, then the universe may not be empty at all. It may be filled with environments capable of supporting life. We went to the bottom of the ocean searching for answers. Instead, we found better questions. Is life truly unique to Earth? Or is it hidden beneath ice-covered oceans, deep underground, across countless worlds? Space exploration doesn't begin on a launch pad. It begins in the depths of our own planet. Because the deeper we explore, the more we realize we're not just studying the ocean. We're discovering the blueprint for life in the universe.